Welcome back, y'all. I hope you enjoyed the keynote. Personally, I'm always really excited to see how incredibly dedicated our team is here at Google, and also how many ways there are for AI and machine learning to use data analysis to learn more about users, problems, and the world. I think we're in for some really cool integrations and use cases over the next few years.
Yeah, absolutely. So up next, we've got a really good array of sessions to get us started. So we're getting ready to get started with those breakouts now. We have 20 total sessions throughout the day, each around 30 minutes long across 3 different tracks. On the big data track coming up, we're rethinking big data, moving from complex analytics to actionable insights.
Meanwhile, for the AI track, you'll learn how managed cloud services make AI possible for every business. And in the industry solution track, you'll investigate smarter marketing with Google Cloud data analytics and AI.
And remember, you can ask us questions at any time. We have Googlers standing by.
Welcome to the continuation of Cloud on Air, the journey from big data to AI. I'm William Verbenep. I lead the product management team for big data services on Google Cloud Platform. Before we start, I wanted to remind you that there is the ability to ask questions, and there are Googlers on call right now ready to answer questions. So as we have this conversation, please ask your questions and do that as part of this discussion. I'm looking forward to those questions as well. So starting with big data in the context of AI, one thing that's pretty clear, and many of the sessions in this event are going to be describing that in a lot of detail, is the huge opportunity of machine learning to bring new dimensions to your data and new use cases to data usage. And so we'll talk about that in many details, but one thing I wanted to point out that we're going to discuss here is that does not exist in isolation. And in practice, the journey to AI starts with data analytics. It's not a magic bullet that just parachutes in and suddenly you sprinkle some AI and everything works differently. It's actually incremental. And in a way, that might come up as disappointing, but really it's not. It's actually a very positive message, because what it means is that all your investment to this point and ongoing investment around analytics is not just useful by itself for the value you're getting from your analytics system, it is also something that works towards your usage of AI and you benefiting from AI down the road. So that's really the way to think about that. AI as a continuation of the investment in big data. And so in this session, we're going to focus on that part of the process and bringing big data to your operation. Let's start with some of the challenges. There's a long list of them. I'm sure 5 of them probably popped up in your head just by mentioning that. So obviously sources, getting data, accessing data, having fresh data, having reliable data, protecting data, sharing it because you need collaboration, you need to let people access it, and yet you have to protect it. Either for compliance reason or just because that's just the right way to do things. And people should only have access to what they need to have access to. There's technical concerns, there is staffing concerns. Everybody who's tried to build those systems is aware with the challenge of doing that. And yet, really, many companies have made it work very successfully. And some of those listed here are examples of companies who've been able to do that with minimal burden because they've done that by leveraging a cloud platform, Google specifically, and we'll be talking about examples of some of these companies and how they have managed to harness big data and get immediate value from analytics, as well as put themselves on the road to AI and ML. Those companies are across many industries, and while the tools are relatively generic, the use cases, of course, are specific to various industries. And so depending on which industry you're in, and we listed here some of the common ones, these are some of the most common patterns. Obviously, there's many more and it's oversimplified, but just to help give a sense concretely of how the services, how big data can be used to power actual business insight. From Google perspective, our business really is data in many ways. Originally, Google was a search engine. It was all about indexing and searching and providing results. And then, obviously, as Google grew and entered new markets, one thing that's been really core to pretty much everything Google have done is the importance of quality data and quality analytics, and of doing it at scale, and of doing it efficiently, such that the cost of operation is very low, such that engineers are really, really productive, and we can focus the time of our engineers on building application, building system, not on administration and optimization. And so all of that, we invested a lot to automate and build systems that handle it natively. And so, from a timeline perspective, you can think of that by following the timeline of the papers that Google has published. And many of those papers are very famous and well established, things like MapReduce and Dremel and others. And so it used to be the pattern for Google where we would invent technology to meet our own needs, publish the paper, and just move on to the next thing. And the paper was there for people to read if they were interested. What would typically happen is that people outside Google reading those papers would want access to those systems, which at the time, before Google Cloud, was not an option. And so what they did, in companies like Yahoo and Facebook and others, based on those papers, re-implementing the technology, and that gave birth, in Yahoo to HDFS based on Google File System, to Hadoop based on MapReduce, and then Dremel and Bigtable as HBase. Like a lot of those were re-implementation of the technology based on papers published by Google. That has changed a lot over the last few years. Not that we've stopped publishing papers. Recently the Dataflow paper, the TensorFlow paper, and there are more coming. So that thread is still happening. But now, as we publish paper, we also open source relevant technology. And so we open source the TensorFlow framework. We open source the Dataflow SDK, which became Beam as we gave it to Apache Foundation. It's now called Apache Beam. And so now the code from Google is now contributed to the community alongside the paper. And we also actually make the service itself available, the actual service that this technology was used to build. And so things like BigQuery for Dremel, Bigtable, Dataflow itself for Apache Beam, TensorFlow. And so it really changes the way where people outside Google can benefit from the expertise and the system built by Google for big data. And that's really a large part of what constitutes the platform as it is today. And so, a way to really simplify the effort and focus on some key initiatives is to think about those three. There is a huge amount of work and really impressive services around modernizing data warehouse. Most companies who've been in business for a while have enterprise data warehouses, understand the need, also understand the cost and complexity and limitation. And so that is probably the most obvious and immediate benefit of adopting cloud-native systems, and we'll talk more about how BigQuery powers that. The second dimension is there really is an industry shift from batch to streaming. To some extent, as an industry, we've internalized the fact that batch somehow feels natural when dealing with data at large scale. While in reality, there's absolutely nothing natural about batch. Nothing in the world happens in batch mode. What is much more aligned with the way things actually work is stream processing events as they happen. And we'll talk about systems that now make that just as easy, just as effective, just as scalable as batch processing, and how streaming is becoming the new normal. And then, as mentioned, the step after that, and in the continuation of that, because it's not a replacement, but it's an extension of analytics using AI and ML, which I'm not going to go into details in this talk because we have many sessions as part of the event more focused on that third part. So let's look at the first one, modernizing data warehouse. The core of that is a product on Google Cloud called BigQuery. And so BigQuery, in a way, you can think of it as it's a cloud data warehouse. It does everything a data warehouse does, but it does it in the cloud. And that's true as a first degree of approximation, but it's actually a lot more than that. In a way, BigQuery is a truly cloud-native services where you don't have to install or deploy or scale anything. You just basically use it and pay based on your usage. You can pay per query, or you can pay a monthly reservation as you prefer. But under the cover, it's really a service that you just consume as you need it. The other aspect of BigQuery that are quite unique is the separation of storage and processing. And in that sense, maybe if I go to the architecture slide, we'll see that there. And so this is how BigQuery is architected, where there is a storage engine, which is basically like a lake for tables. So think of GCS or other cloud object store, infinite storage for object in the case of GCS or object store. Well, BigQuery is the same thing, but for tables. And so you don't have to deal with file formats and optimizing file and how do you do streaming ingestion. You just have tables as first-class resources. You ingest data in table, you share tables directly. And then there is BigQuery based on Dremel as the query engine. And so in that context, again, serverless, what it does is it executes query for you, where all you have to do is define the query you want to run, submit it to the system. You don't have a cluster to set up or manage or optimize. You just send the queries, and we do everything to run the queries for you. And so those two pieces together make BigQuery as a data warehouse. But because they're independent, also make BigQuery more like a platform where the storage, the data in storage can be accessed through other systems. We'll talk about Hadoop and Dataflow and other processing systems. And the query engine can query data outside of the storage system. And so in that sense, it's really more a platform for analytics, which happens to do everything a data warehouse needs to do. Obviously, high-performance SQL queries, ad hoc analysis, reporting. And because it is serverless, it means that when you run a big query, you have access to a huge amount of data. We have queries that process 1 petabyte or more in minutes, which is not something you could realistically do if you have to pay for that capacity all the time. And so that's BigQuery, really at the heart of a data warehouse migration that gives you the infinite storage, because you're just paying for you're just paying for storage separately from having to scale a cluster. So you get infinite storage, and you get high efficiency in terms of the users and their ability to focus just on what they want to get done, as opposed to optimizing for the system itself. Of course, BigQuery is one part of the platform. There are things upstream, there are things downstream. And so here we see a relatively typical architecture for where BigQuery is being used, where you can ingest data both in streaming mode, and we'll talk more soon about the streaming model for the platform. The thing that's important in the context of data warehouse is that BigQuery has a streaming ingestion API, and you can just pump events into tables, and they automatically get added, and they're immediately queryable in the table. It also, of course, supports batch ingestion, where you can bring files, load the files into the platform, and make them available. And then downstream, data in BigQuery is available to a large array of tools. Obviously, every tool that can run SQL, and so all the BI tool and data visualization from our partners, Google native tools like Cloud Data Studio, spreadsheets. So all of those have direct access, and that's more for business analyst type audience. In addition, for data scientists, tools like Data Lab, for example, which is a Jupyter notebook as a cloud service, can also tap directly into BigQuery and access the data. So here's an example of a customer, Ocado, in Europe, online retailer, using BigQuery in many, many ways. That's one thing that's interesting about BigQuery as well, is it's not necessarily a data warehouse for a specific team or a specific purpose. It is a global data warehouse where obviously different use cases can be applied, but sharing the environment and sharing the data. And so Ocado uses it for supply chain, optimization, logistic, inventory. They also use it for marketing use cases. And that is a very, very common use case for BigQuery, and one that's applicable across almost all industries, is the fact that people really want to get a complete view of their customer interaction, their marketing activities, and BigQuery is uniquely well suited for that. For one thing, BigQuery has connectors to all the relevant data sources, and in the case of those already at Google, like AdWords and DoubleClick and others, that's actually built in. All you have to do is go to BigQuery Data Transfer Service and select the destination, the data set where you want your AdWords, your DoubleClick, your YouTube, your Play Store data deposited, and it gets brought directly into the platform. Obviously, you want to complement that. It's not just data from Google or other SaaS vendors. You have your own data about your customer. And so as we saw earlier, there are easy ways to bring it. There's also easy ways to prepare it. Bringing the data is one thing, but actually most of the work is not physically bringing the data. Most of the work is preparing the data, putting it in the right shape, enriching it, maybe anonymizing it, joining between relevant data sets. And so data flow, which we'll talk about, is a perfect runtime for that. And we have tools on top of it, especially Data Prep, which is a very easy graphical tool that requires no coding experience, no SQL experience. Anyone who basically understands the data can load that UI, interact with the data, and define a pipeline. And so we see that, well, all over the place, but we see that a lot in marketing use cases, empowering line of business managers or business analysts to bring new data set very quickly, clean it and prepare it, and then bring it in BigQuery alongside other data, and then expose the result in dashboards, in Data Studio, or in partner tools for analysis. Again, very common example. So having talked about that first dimension, which is the modernization of the data warehouse, which provides so much value and is such a clear mapping from where most people are today to a successful big data in cloud system, the next step after that typically is revisiting the reliance on batch processing and moving more towards streaming as the default. And so, again, per industry, the use cases are very different, whether it's IoT or mobile application or customer interactions, with your website or your web store. Like all of those have very different goals, but in the end, they're all about real-time event processing. And the value of real time is becoming more and more important. Gone are the days where it's fine to take a 24-hour cycle to have good recommendation on what you present to your customers, or understand your customers better, or alert on anomaly. Like all of those things, really, literally time is money. Literally, the faster they happen, the better. And that's where stream processing comes in, which used to be really complicated to do at scale, at least. Used to be reserved for the most advanced, most high-value scenarios, and so people in the banking industry have been doing it for a long time. But it really was the special case where batch was the rule, and so we're really flipping that because we're offering services that make it just as easy. And the way I can say it's just as easy is because it's the same tool. Like literally, the pipeline you create in batch mode in Dataflow, which is our serverless pipeline execution engine, that same pipeline can run in stream mode. And so you write it once. So, by definition, it's not any harder. You also get the benefit that the same pipeline can run in both modes. Because, let's face it, the transition to streaming doesn't happen like that. You cannot just magically have all of your partner, all of your sources move from a streaming system, from a batch system to a streaming system. And so it's a transition. It's an incremental transition. As this transition happens, you really don't want to be re-implementing your data preparation logic. You want to keep using the same pipeline, but just be able to adapt to the new sources. That's what Dataflow gives you. I mentioned Beam earlier. So Apache Beam is the SDK for Dataflow. Beam comes from the B of batch and the EAM of stream. And so that's fundamental to the Beam model to unify batch and stream. And Dataflow is one of the environments in which you can deploy Beam pipeline. You can also run them on Spark or on Flink or other open source runners. In Dataflow, what you get is a serverless execution model where you have nothing to install. You just submit your pipeline, and then we auto-scale it for you in batch mode or in stream mode, and you only use the resources that you actually need to process your job. And so that's really the kind of tool that is powering the transformation towards stream. Another aspect is PubSub, so upstream. Obviously, before you can process events, you have to reliably collect them and distribute them to subscriber. That's what PubSub does. PubSub, publish, subscribe. The pattern is very well known. There's nothing new about the pattern. What's new about PubSub is just like BigQuery, just like Dataflow. PubSub is a serverless system where you don't have to deploy anything, you don't have to scale anything. It is a global system managed by Google. All you have to do is create a topic and then start posting events and subscribing to the topic. And Google takes care all over the world of collecting the events, bringing them to the appropriate cloud data centers, and then delivering them to the consumers. And so that chain of serverless products from PubSub to Dataflow to BigQuery and its ability to ingest data. And of course, along the way, all the machine learning APIs are available to run queries on the data in stream mode or in batch mode to do natural language processing or video detection, anomaly detection. All of those things you can do on the fly as you ingest data and really build a real-time system into this next generation data warehouse. And since the theme of this event is really around the transition to ML, I want to point out another really important reason why you want a data ingestion and preparation system that works both in batch and stream without having to change your pipeline is that in machine learning, one of the things you have to do is prepare your data for training. Once you've trained your model, it's really important that the data on which you're going to run your model at prediction time goes through the same preparation steps. Otherwise, you get really unreliable results if you don't prepare that the same way. Well, most of the training happens in batch mode, and so you probably need a batch pipeline to do that. A lot of the prediction happens in stream mode, and then again, that's why you need that pipeline to be able to run in both modes. That's another benefit of Dataflow in that context. So here we go. So yeah, Dataflow, as I was mentioning, those three things are the unification of batch and stream and the operational excellence. That's what runs Google. And so in terms of optimization, efficiency, reliability, we have over 15 years of experience, incrementally improving systems, and Dataflow is the result of that. One customer example is Bright Cove, uses Dataflow and PubSub upstream heavily to, in real time, analyze video delivery pattern and usage and logs and get real-time information about what's going on. And we see that across all the customers. A big part of that is when they release a new update, when they introduce a new feature, when something changes, either on purpose or accidentally, they need to see right away the impact it has. So they know if it's good or not, they know if they have to address it, and they can take action. And that's what Dataflow provides as part of the move towards streaming. And so here's that same pipeline. One thing that you notice is that in addition to those blue hexagons, PubSub, Dataflow, BigQuery, which are a pure serverless cloud-native experience based on Google's technology, you also have options. So instead of PubSub, you have the option of running Kafka if you choose so. You can run Spark for your Dataflow pipeline. And so the platform is entirely open. So not only is Dataflow itself based on open source, you can bring other open source technology, and we make that very easily on the platform. One way we make that easily is via data connectors. And so ensuring that Spark and Hadoop have access, direct native access to cloud storage, to Bigtable, to BigQuery, and can be used as part of the platform. You don't have to choose between cloud native services and the best of open source. You can mix and match as you see fit. And so we've gone an extra step to make that possible and easy. We've actually created a service, Cloud Data Proc, who is dedicated to bringing the best of open source data processing to Google Cloud as part and integrated with the larger platform. And so if you look at Data Proc, what it does is it will deploy a Hadoop or Spark cluster in Google Cloud. It will do that. It will do that very effectively and very quickly. And so you can deploy a pipeline in about 90 seconds. And at that, not a pipeline, a cluster. You can deploy a cluster in about 90 seconds. At that point, that cluster is ready to run. Because of the connectors I mentioned earlier, you don't have to worry about bringing data into Hadoop or into Spark. You just start that cluster and it starts working right away. It really changes, with that direct access to the data, with the speed of provisioning, with the per second billing model, it really changes the way people use Hadoop and Spark compared to on-prem. In one way, it doesn't change anything. It's the same Hadoop and Spark. So all your tools, all your pipeline just work unchanged. That's the good part. What it changes is the operational experience. And we see people moving towards much more dynamic cluster that you just spin up, do something, and then you can go on and continue and just shut them down or just do another task and keep them for a much shorter time period, and have different teams just create their own clusters as they see fit. It also, that's kind of the foundation of it. The tool itself, now support workflows and the ability to automatically terminate a cluster after a job, or to terminate a cluster at a given time, or if it's been idle for more than a certain time. So we give you all the tools to really help you optimize your usage and bring the large ecosystem of Hadoop and Spark, but bring it in a way that is integrated and optimized on Google Cloud and can be used in conjunction with tools like BigQuery, like Dataflow, and like PubSub. So this is describing the storage integration, which I mentioned earlier. One thing I did not mention, which you can also see on this slide, is the integration with Stackdriver for monitoring and logging. And so all your cloud services, including Dataproc for Hadoop and Spark, are available or are monitored via Stackdriver. Gives you one place to have full visibility into all the execution, the performance of all those services. So trying to put it all together, I'm not going to walk through that entire chart. There's just way too much here. This is a recap. Some of the services here we talked about, others we did not talk about, and we have sessions as part of this event that go into more detail and lots of resources on the web. But this is kind of the overview of the data platform, the data processing platform on Google Cloud across the life cycle of the data, from the point of capture, pre-processing, typically with Dataflow, batch or stream, storage of analytics data in BigQuery, Bigtable for NoSQL, GCS for the global object store, all the processing system. We talked about BigQuery as a SQL engine, Dataflow, Dataproc, and ML engine in that context is, again, as we're saying, is another usage of the data that you brought for analytics. And then all the tools on the right side, partner tools, and as well as Google tools that provide really an easy and well-integrated access to the platform. And speaking of partners, I also did not mention the ETL and integration partners, very rich ecosystem of partners who can bring data from your on-prem application, from your SaaS services onto Google Cloud Platform. One thing that I want to finish with is that what I've described around serverless and the operational efficiency, that is transformational, and that's something that really we've been preaching for a long time, because that's how we run internally. It used to be misunderstood. It's now becoming front and center in the industry, and it was very validating to see this Forrester report focusing on Insight platform as a service, another term for serverless or cloud native. and recognizing Google's performance as the best platform and the only leader for offering a complete portfolio of analytics services in the serverless model. So please have a look at this URL, has examples of more solutions. I just mentioned a few customers and how they use the platform. We have much more detailed information in those use cases. Please have a look. Please attend the other sessions. I hope you enjoyed the event, and thank you very much for your attention.
Continually discovering new problems and discovering effective solutions for those problems.
Yeah, absolutely. I think that's a perfect
I'm going to actually interrupt you because we're back with big data as well. We want to welcome everyone back and just kind of get to everyone here. And I think we're going to talk about what's coming up in round 2 of the sessions. But
Absolutely.
if you wanted to finish your thought, you can have it now.
No, that's pretty much the thought that I had. I think it's really this opportunity to find things which people can focus on and take advantage of. But I'm really looking forward to the next tracks that we have. Now that everyone's back with us, we're going to rejoin the sessions.
Right, and so as just a reminder, there are 3 sessions. You can switch between them, but we've got Dan McClary with Reimagining Data Warehousing. We've got the AI, and you're on.